Hannon Mathematics Awards has been running for 17 years. Many of our past winners have completed their studies and embarked on their careers in academia or other professions. This evening, we're very delighted to have Mr. Jay Chan, winner of the 2006 Hannon Mathematics Awards Gold Award, to be with us tonight. Mr. Chan is a district engineer at the Civil Engineering and Development Department of the Hong Kong SAR government. He will share with us his work and how mathematics can tackle the impacts of climate change with us. Mr. Adriel Chan, Vice Chair of Hannon Properties, will moderate the session. May I now invite Mr. Jan and Mr. Chan to come on stage.
Thank you. Thank you. What a wonderful evening, Honorable Mrs. Carrie Lam. Thank you for joining us again. I remember I was here 3 years ago with a guest on your table, Dr. Owen Koh, having this discussion about how mathematics affected his career and his life. And today I get to speak with Jay Chang, the winner of the Gold Award in 2006, about how mathematics has affected his life and how it has changed his career. He won the 2006 award, which actually coincidentally is related to his work in some way as an engineer with a CEDD. So maybe I'll start off, Jay, could you tell us a little bit about what it is you do for the CEDD?
Sure. Good evening, everybody. I work as a civil engineer in Port West Division of CEDD, HKSAR government, and I mainly provide the advisory service on the marine works projects from engineering point of view. And the most interesting thing is that I am also the leader of a computer modeling team. We are developing a computer wave model to simulate the wave impact on the shoreline of Hong Kong and formulate the future enhancement plan.
So that's a handful. We live on an island. There's a huge coastline. I think as a resident of Hong Kong, my first question and my biggest concern is what is the danger to us from extreme weather events, from climate change, from typhoons? We had Mangkhut several years ago. And how do you work to keep us safe?
Yeah, you're right. Hong Kong is really vulnerable to typhoon attack, and we got long shoreline, about 1,100 kilometer long shoreline, and actually our department formulate quite a lot of plans to enhance the resilience of the city. For example, we've already built a 600-meter long wave wall along Cheung Kwan O, and also upgrade the Aberdeen breakwater. And more related to mathematics, maybe you are interested in it. We are working on a wave model, and in that wave model, we try to use mathematics to simulate the wave impact along the Hong Kong shoreline. And also, when civil engineering plans for the future under the threat of climate change, we talk about probability. We are having some studies about the joint probability of extreme wave height and extreme sea level. For example, some statistical tools just like GEV, generalized extreme value distribution, is used for the analysis. And based on the scientific and mathematical study result, we are more confident that we can combat the climate change.
So when you say extreme waves, how extreme is that? 5 meters, 10 meters?
3 to 5 meters.
3 to 5. So 3 to 5 is already extreme.
Yeah, 2-story high.
Okay. So obviously there's been concern being a coastal city that with climate change and the rise of sea level, we may become flooded. Is this a real risk, and is it something we should worry about?
Actually, there are quite a number of civic organizations predict the flood extent of Hong Kong in the future sea level rise scenarios. But I may say that we need to consider the study results very carefully whenever there are such kind of research, and some of the results are really frightening. We need to know the source of data they use, the modeling methodology and assumptions made. But personally speaking, I appreciate those organizations because they serve as a wake-up alarm call to us. We need to enhance our preparedness and awareness to climate change, and we aim for carbon neutrality in the future.
So if I can take half a step back, wave height, 2 to 3 meters is already very big. What are the major factors in establishing what will create a big wave? Is it the water depth or?
The major parameters should be water depth is one of the parameters, and the most important one should be the wind speed. You know, the Super Typhoon Mango or the one before Hato had very high wind speed, so that makes the wave height very high. And also, if you are a surfing lover, you consider the wave height and also the type of wave. And it depends on the slope of the shoreline, and unfortunately, there is no good places for surfing in Hong Kong.
So a note to our surfing friends. So if we shift a little bit to mathematics, how was it that your path attracted you to mathematics? And then how did that path lead to engineering?
I may say that I'm blessed with number sense, so I am attracted to maths naturally. And I also enjoy this sense of achievement and the process of solving problems. So
Solving them elegantly.
Elegantly, yeah. So I think I match with civil engineering perfectly.
So along your path, what would you say is one of the more interesting? So you studied at Hong Kong University, is that right?
Yes, the University of Hong Kong.
A decent school as well, although we're in the presence of much better schools. But what were some of the more interesting classes that you took?
I may say that I studied a master's degree in the University of Southampton in the UK, and I would like to talk something about the shoreline management plan that I learned from the UK. In UK, there is a shoreline management plan. Under this plan, the government estimate the coastal risk scientifically, and then they plan for the shoreline development and the land planning along the coastline. And this course made me understand that even hard engineering measures is not the only solution. We need to brace ourselves we need to get prepared to the climate change and have the emergency preparedness for it. And we also need to have a holistic land planning along the shoreline.
So the solution cannot only be solved by engineering and mathematics.
Not only
we need some social and government solutions as well.
Yeah, we are working hard on it.
So tonight we have a lot of young people with us, a lot of students, people who probably aspire to be like you. What would your advice to them be? They're in high school right now. They're doing what you were doing in 2006.
I think it's the time to choose the future curriculum or even future career for students. And I would like to make some advice to you, is that follow your heart. No matter what curriculum you choose, your mathematical foundations can play an important role in the future. Just keep using your analytical and logical thinking in your future, and That's it.
As Professor Smoot mentioned just now in the video, there's a lot of practical applications of mathematics to our daily lives, to different departments, engineering and others. So if you were to go back to 2006, what would your advice be to yourself, or what would you do differently?
I may say that I should develop more interest, not necessarily related to maths. Maybe.
This is real life advice. Real life advice. You should be very good at math, but also develop other interests.
Yeah. Even Steve Jobs, he dropped in on a calligraphy course in college, and it made him get this aesthetic vision. Years later, he can introduce the multiple typefaces to the Mac. I think if I develop more interest in appreciation of art, maybe I will be a more interesting person.
Well, here you are sitting on stage speaking to the chief executive of Hong Kong. I think you've done very well for yourself.
So nervous.
I'll bring it to a close with one more question. You mentioned Steve Jobs just now, and at our dinner table we discussed people like Albert Einstein. Even Einstein, he was very interested in philosophy and art as well, besides physics and mathematics. Do you have a role model, or do you have somebody that you look up to? Is there a professor or a famous mathematician that you aspired to be, or that you aspire to that you would recommend our students here study?
I'm sorry, I don't have any role model, but
his teachers were very, very good.
Just be yourself is okay. Yeah.
Very good. So thank you so much. I've really enjoyed this. I think the takeaway is that climate change is a problem for us here in Hong Kong. The solutions will not just be led by engineers and mathematicians, but it requires a holistic approach. So math will not solve all of our problems, but if I can make one comment as a piece of advice to you, or maybe the young people here, yes, I think that developing your other interests is very important, but to have the anchor and the depth of knowledge in something hard, a hard science or mathematics, is very important and very valuable. And I suspect that if you were not as good at math as you are, you may not have gotten this far in the CEDD. So while we all have other things to explore, it's very important to go deep in this one subject. Great. So thank you, Jay. We hope to see you at future events, and maybe you'll become more involved in the Hang Lung Mathematics Awards. Thank you.
Thank you.
Thank you, Mr. Chan and Mr. Chan, for your lively conversation. As a token of appreciation, may I invite Mr. Chan to present a memento to Mr. Chan. Thank you, Mr. Chan and Mr. Chan.